What is up? Howdy. What's going on, everyone? Playlists can have more than 3 songs. Is I think your confusion. Playlists can have 1 billion songs. Playlists can have as many songs as they want. My incorrect solution is an incorrect solution. It does not do what it's supposed to do. That incorrect solution can't handle playlists with more than 3 songs. It's an incorrect solution that's saying, hey, you better be tested with more than 3 songs, because if your tests only have 3 songs, you're not really testing your code. I think you're misinterpreting what the incorrect solution names mean. All right, so today we want to talk about polymorphism, and the course, of course, is starting to really heat up at this point. If you've been falling behind, I really gave this warning at task 4. Once we hit the task 4 expected deadline, where is it? Oh, I have it collapsed. Once we hit the task 4 expected deadline, that's really when things start heating up, is leading up to that deadline. Unfortunately, about half the class just kind of didn't even make a submission before that deadline. So now that all of you are starting to catch up to, holy shit, this course is going fast and it's about to end next week, if you haven't realized that yet. This goes very, very, very fast. I'm sensing a lot of that panic out there. I mean, at this point, you already fell. If you're still working on task 4, you're pretty far behind at this point. I don't have too much optimism that you'll be able to finish the course in time for next week. But, I'm still rooting for you. I hope you can. But it's a long shot at this point. My goodness, there's a lot. Piazza's starting to heat up. Office hours are starting to get longer queues and everything. It's going to be harder to get help at this point because you're all starting to overwhelm me and Gerline at this point because y'all waited so late. But it is what it is. Can't say it's not expected, but it's always tough to watch so many students fail because they waited too long. But it is what it is. So the quizzes, Gerline has done everything on her end. It's waiting on me right now for the quizzes. Probably tonight. I want to do it right after lecture, but I don't think I'm going to have time after lecture and office hours. But tonight I'll finish up processing the quizzes and then post the results to Autolab for the last quiz in 2. Oh, my brain. Classes 2 and data structures 2. Goodness, I couldn't think of that. We'll get those results out there for you. All right, but today, polymorphism. This is a really, I think it's a really fun topic. I don't know if anyone agrees with me. Developers out there do. I don't know if students do. But I think it's a really fun topic. My mug has a lot of green on it, so it always looks funny in the green screen. But let's get on with it. Polymorphism. Is, in my opinion, the big payoff for inheritance. So we learned about inheritance, it seems like an eternity ago, but it wasn't even all that long ago, a few weeks. And inheritance is cool and all, don't get me wrong. And in the inheritance lecture, I sell why inheritance is important. It lets us reuse code between classes. And then if we have a lot of very similar classes, we can factor out all of the common functionality into a separate class, and then have them all extend that class to inherit all of that state and behavior. And that is cool, don't get me wrong. But I think, in my opinion, polymorphism is the big payoff of setting up inheritance. So let's see what polymorphism even is. And since it was a while ago, let's refresh inheritance quick. Inheritance is when we are inheriting the state and behavior of another class. So we said weapon and health potion have a lot of common behavior. They're both items in our game. So let's create a separate game item class that's going to have all of the common state and behavior. So every item in our game is going to have a location in the game. We're treating this as a two-dimensional, an XY grid. I'm imagining a top-down, overhead view for the game, and then a grid-based system to see where the players and items are, the whole game world. So they have an X location and a Y location. And items can be used. We're going to refactor this code a little bit. We're going to change it up. We're going to have use take a reference to a player. We didn't set up the player class last time when we did inheritance. But we're going to change this around to show some really cool uses of polymorphism. But for now, game item had a use method, which is also inherited. And then if we want to change the inherited behavior of this use method, we can override the method with a separate definition that's specific to the class that's extending game item. So that was inheritance. Hopefully that's all review. You should all be well versed in inheritance. We've already had the inheritance quiz last week. You should know about the super constructor calls, the which method is being called. If I have an object of type weapon, it's this use method. If I have an object of type health potion, it's this use method if I call use. We should all be well versed on that leading into this lecture. So let's get on to polymorphism and what polymorphism even is. Oh, sorry, my lead-in sentences are off a little bit. We still got to talk about inheritance because we got to expand what we know about inheritance just a little bit. So with inheritance, we had this weapon class, and I just want to isolate this one so we can talk about just one class here. We have the weapon class, which extends game item, and game item, which implicitly extends object. If you don't explicitly extend anything, your class extends the object class, which is built into Java, and absolutely everything, either directly or indirectly, does extend the object class. So the weapon class gets all of the state and behavior of all three classes. Anything defined in the weapon class, so damage, get damage, and this overridden use method, and its constructor, all of this is built into the weapon class. It also has X location, Y location, and the inherited use method, which it did override, and the game item constructor, all from the game item class. And then from the object class, weapon indirectly through the game item class does inherit from the object class methods like toString and equals from that class. So we get the state and behavior of all three classes in the weapon class. And we have kind of a term for this. I'm usually not too big on vocab, but I think this one's a little useful to understand the concept here, is that if an object, or if a class extends another class, objects of that type are that type. And this is called an is-a relationship. So when we create an object of type weapon, that weapon object is a weapon. That one's obvious, hopefully. And the weapon is a game item, which is where the concept starts kicking in a little bit. If a class extends another class, that class is that other class. So a weapon is a weapon is a game item, and a weapon is an object. In a very real sense, a weapon is an object. A weapon is a game item. This is... Oh, Gerline. Well, I don't usually lose my train of thought. So weapon is a game item. Weapon is an object. So I always like to talk about the shape analogy here. So we know this from geometry. You have this relationship where a square is a rectangle is a quadrilateral, a square is a quadrilateral, because a square has all of the properties of a quadrilateral, has all the properties of a rectangle, but it also has some extra properties that are unique to being a square, namely the sides are all equal length. And all right angles that it inherits from being a rectangle, and then four sides, which inherits from being a quadrilateral. So we're used to this is a relationship in geometry. It's the same kind of idea. Of course, we're talking about state and behavior instead of properties of shapes, but it's the same kind of idea where a square is a rectangle. So anything that a rectangle can do, a square can do as well, and a square can also do other things. So polymorphism, finally. Polymorphism, if an object is a type, if it has the is a relationship to another type or to any type, then it can be stored in variables of that type. That's polymorphism. There's always a strong confusion among students of where the line between inheritance and polymorphism is. This is the line right here. If you're storing an object in a variable that doesn't match its type, because obviously we can store an object in a variable that matches its type. We can store a weapon in a variable of type weapon. We don't need polymorphism for that. That's just the way we do things. But as soon as we take an object in one of these is-a relationships and store it in a variable matching that is-a relationship, that's polymorphism. That's when we're using polymorphism. Everything else is inheritance. The overrides, the inheritance, inheriting state and behavior, the what we'll talk about later in this lecture, abstract classes and interfaces are actually both inheritance, not really polymorphism. Polymorphism is when you're storing objects, and more specifically to reword this, when you're storing objects of one type in a variable that doesn't match its actual type. That's polymorphism. You've kind of been doing, you've been doing actually, I haven't thought about it quite that way. I guess we have been. Whenever you're using generics, you're kind of using polymorphism. But I don't know if I'd really call that polymorphism. Until we use the equals method, there was one example when we used the equals method on a generic type, then we're treating that type as an object of type object, then I would call that polymorphism. But we have, when we did binary search trees, when we gave it a comparator, and we gave it a comparator of type comparator, it took a variable type comparator, but we actually gave it an object of type int decreasing or int increasing, or song title comparator, Bayesian rating comparator. We gave it objects that didn't match the type that it asked for. And that worked because those types extended the type it was asking for, namely comparator, so that was a legal assignment. And I kind of just said, that's polymorphism, don't worry about it yet. But we will revisit that. I'm going to go to IntelliJ and actually modify that code to explicitly use polymorphism and explain what was going on with those. So there we definitely were using polymorphism. Yeah, generic types, maybe I would call that polymorphism. I don't know, not really though. It depends. You'd really have to dig into the grammar of it and get technical about it. Maybe though. I'll stick with that with a maybe. Because the generic type can be treated as type object. I think that's where it becomes polymorphism in my mind, at least. So, polymorphism. Poly means many. Morph means forms. Polymorphism, many forms. I'd feel bad if I didn't show that on at least a slide whenever we talk about polymorphism, because it's like one of the first things a lot of people say. Polymorphism, many forms. So polymorphism means many forms. A weapon has 3 separate forms. It can be treated as a weapon, it can be treated as a game item, and it can be treated as an object. So 3 different types a weapon has, 3 different forms, and it can be treated as any one of those 3 forms. Which means any one of these 3 assignments is legal. This code compiles, this code runs, everything's perfectly fine with this code. And this is the first time we're really seeing polymorphism. We're creating a new weapon object, storing it in a variable of type weapon. Big deal, we've been doing that forever. That's how we expect strong typing to work. But here we're going to start seeing the lines get blurred and the rules get bent a little about strong typing. I always say, if you create a variable of type double, it can only ever store a double. If you create a variable of type weapon, it can only ever store a weapon. We're going to bend that a little bit when we create a variable of type game item and assign it a weapon. So we're creating a new weapon object, just like we did in the previous line, but storing a reference to that weapon object that's living on the heap in a variable of type game item. That's a valid assignment because a weapon is a game item, because weapon extends game item. And this works indirectly as well. We'll create a new weapon object on the heap and store a reference to it in a variable of type object. Because weapon is an object. Because it extends game item, which extends object. So it indirectly extends object. All three valid assignments. All this is legal code. In fact, any object ever, they all are of type object. They all extend either directly or indirectly the object class. So if you create a variable type object, you can store a reference to any type ever, any object at all. Our last quiz is scheduled on July 4th. That is correct. So July 4th and then July 6th is all the makeup quizzes. Which the university does not recognize July 4th as a holiday, to my knowledge. Excuse me. But luckily our lecture's early enough. If you're doing anything for the 4th, there's plenty of time to have lecture and then go do something like I'll be doing. All right, so all these are valid assignments. So what are the implications of this? And the very first thing, I think polymorphism is so strong, I don't really have to sell it to you. I will by the end of this lecture. But I'm so confident you're going to love polymorphism that I'm going to start with the downsides. So the downside of polymorphism is when you store an object in a variable that doesn't match its type, something that's up its chain of inheritance, its inheritance structure, you can only access the state and behavior that matches the variable type. So even though you can store anything in a variable of type object, if you have something in a variable of type object, you really can't do much with it. Namely, you can call toString, you can call dot equals, and a few other methods, hash code, some other things that we haven't really talked about in 116. But you can't do much with it because you're restricted to the functionality known, the state and behavior known to the variable type. So we define the getDamage method inside the weapon class. The weapon class itself has a getDamage method. It didn't inherit it from any other class. It defined it inside the weapon class. So in our variable of type weapon, since we're storing our weapon in a variable of type weapon, weapon1.getDamage, that's a legal method call. It matches a method that's known to the variable type. Everything's fine. But GameItem doesn't know about the getDamage method. In fact, classes aren't even aware of any other class that extends them. The GameItem class is not aware that the weapon class or the health potion classes even exist. The inheritance structure is definitely a one-way. It's kind of like a linked list. Only the classes that extend a class know about the inheritance relationship. GameItem doesn't know that it's being inherited or extended. Object, as far as the object class is concerned, it's the only class in all of Java. It's not aware of any other classes that extend it, that inherit it. So the GameItem class has no way of knowing that the getDamage method exists, which means from weapon 2, this variable of type GameItem, we can't call getDamage. That is not a valid method call. This code does not compile. If I comment this line in, I'll have compiler errors, and the project doesn't run. The compiler says, what the hell is getDamage anyway? It doesn't know that that method exists. And same with weapon 3 of type object. We're not calling toString. We're not calling equals. We're trying to call getDamage. Object doesn't know what getDamage is. Does not compile, does not run. Even though weapon 2 and weapon 3 do in fact store references to an object of type weapon, you can't use the weapon specific stuff. You have to use only methods known to GameItem for weapon 2 and methods only known to object for weapon 3. And this is why when we had generic types, we can call toString, we can call equals, and that's about it. We can't do anything else with our generic types. But we can do those two things because they're in the object class, which every object extends the object. Every class extends the object class, so we can call those two methods, but not much else. So as long as the type of the variable knows about a state or behavior that you're trying to use, then it's a valid call. So we're going to refactor the use method to take a reference of a player. What's up, Kazu? And then it'll take that player reference and then do whatever it's supposed to do. Health potions, it's going to increase their health. Weapon, going to increase their damage output. So weapon1.use, that's a valid call because the weapon class has a use method. Recall that weapon extends game item, which game item has the use method defined in it. So the weapon class definitely knows about the use method, even if it's not defined in the weapon class. If it extends it, it actually is because it overrides it in this case. But even if it wasn't, it does know about the method because it inherited it from the game item class. So it has a use method, it knows about it. From the weapon class, that's a valid call. And also from the game item class. Game item class, this defines a use method that takes a reference to a player. So from our variable of type game item, we can also call that use method. And the key point, I think it's on my next slide, the key point here, and the big thing we'll talk about when we get to the memory diagram, is that we can only call the method that's known to the game item class, and the game item knows about the use method, but when it's called, since the actual object that it refers to is of type weapon, we actually do get the overridden use method call. And that's probably the key point, the key thing that it, actually not even really, but the key thing that I'm looking for on the memory diagrams, but kind of not because, well, I'll explain in a second. And then in the object, the variable of type object, we can't call use because the object class, it's not toString, it's not equals. We're not going to be able to call it here. So the type of the variable determines which methods can be called. The type of the object determines which method is actually called. So that's our key point. I want to test this. So what I meant when I said I'll explain in a second. I want to test this on the quizzes, but if I tried to call this part, I'll definitely test you on. But you already were tested on this in the inheritance quiz, so it's not that big of a deal. But the type of the variable determines which methods can be called. So if I gave you code where I'm trying to say weapon3.use of player, you'd have to tell me that it doesn't compile and all that. But I told you earlier in the semester, every time I give you a quiz, I'm guaranteeing that it will compile. There's no trick questions where the answer is like, there's no memory diagram because this code doesn't compile. I'm not pulling any tricks like that on you. I could, maybe sometime in the future, I'll have quizzes with different formats where I say, here's 4 programs, which one compiles, and it has to go by the variable types and all that. But that's not what's going to happen this semester. Every quiz is, here's code, it will compile, write the memory diagram. So this one's going to kind of be automatic for your memory diagrams on your quiz next week on Tuesday. But for when you're writing your code, this is always something to keep in mind, that depending on the variable type, that's what's going to determine which methods can be called. But when you do call the method, if it's a legal call, then you do get the method matching the type of the object. So even though the variable type is game item, which determines whether or not we can call the use method, which we can in this case, when we call it, we still get the overridden use method that's defined in the weapon class. It still goes by the object. So the difference between the variable type, when the variable type matters, and when the object type matters, is important to know. Variable determines what can be called. Object determines what actually is called. Okay, so now I have to sell polymorphism. Why would we ever use this? Why? Oh, I didn't even move my face. What am I doing today? I'm covering up bullet points. Let me just shrink myself down so I don't have to pay as much attention to what I'm covering up. So why even use polymorphism? All it does is restrict functionality. That seems kind of lame. It just lets us say we have an object of type weapon and we can't even use all of its state and behavior because we're storing it in a different variable. We're storing it in a variable of type game item. Seems pretty lame. So why use polymorphism? Now there's two big selling points that I'm going to show. The first one is we're going to simplify other classes using polymorphism. So in the previous slides, we were just, let me go back one. We were just assigning, we're creating a new weapon and just straight up assigning it to a variable of type game item. We wouldn't actually do this. Just so you know, this is just for the lecture example. It's fairly rare. Actually, personally, I do this every once in a while. There are some reasons to do this, but not really very compelling reasons to have a local variable of your method that's only used within that method that's going to be of a super type instead of just putting this weapon in a variable of type weapon and having access to all of its functionality. Why not just have access to everything, all the functionality? That's almost always going to be the case, that you want to just store all these weapons in variables of type weapons. This is only for a lecture example that you would do this. What you will do in real life, in the real world, on your jobs, and all the time, anytime you're using object-oriented programming, you're going to almost always do something like this. If your project is sufficiently large, there's going to be opportunities where this will save you. Is when that assignment is made across a method call. So in the player class, if we want players to be able to use weapons and health potions, way back in the day, 2 weeks ago when we learned about inheritance, we would, yesterday when we didn't know about polymorphism even, we would create a method called probably use weapon that takes a weapon, and a method called use health potion, which takes a health potion. So we'd have two methods that do pretty much the same thing. They're just going to call the use method on that item and pass a reference of the player that's using the item, so the item can do whatever it's supposed to do when the player uses it. And that's, not terrible. But what happens in the example where we have hundreds of game items and we want to constantly add new features to our game with new types of items, and we're going to our player class and adding a method for every single possible item that can be used. That's going to get tedious. This code's going to get really gross. We're going to add 3 lines of code, 4 if you count your blank line, to separate some methods to make it a little more readable. And it's just going to get painful to add new items to your game. And also, everywhere around your project, you're probably going to use weapons and health potions. Other places in your project, you're going to have separate methods, separate data structures, separate things for every single type of item. That's not what we want to do. I want one method to rule them all here. I want one use item method, have it take a game item, and now this method can be called with an argument, with any argument that extends game item. So this one method works for health potions, it works for weapons, it works for bow and arrows once we implement that and have it probably extend weapon, or swords that extend weapon, which in turn extends game item. Anything that is a game item, you can call this method with that object. So this is where polymorphism starts to get really powerful. This is my first selling point, is writing methods that are coded to the super types of the types that you want to use. And then that one method is used for every single type. Now, when I create hundreds of types and I'm adding new types of game items, as I'm expanding my game and adding new features and everything, guess what I don't have to do is update the player class at all. I got one use item method. It works for every item, everything that extends game item, even if I haven't even thought of it yet. This method works for them, for even objects that don't even exist yet, of types that don't even exist yet. This is what we want. This is how we use polymorphism. So this code can be as generic as possible. Just work with generic game items. When a player uses an item, call that item's use method, which takes a reference to a player, which we have in this. So whatever player is calling use item, this player is using that item. Then the item does, increases HP, increases damage dealt, or whatever that item is supposed to do to this player. So this is where the restriction does come in, is important here, is that only methods known to the game item class can be called here. And this is why it's really important to have the game item class know about the use method, or in general, whenever you want to leverage polymorphism like this, you want to write a generic method that works for a lot of different types. Make sure that the superclass contains all of the methods that you'll want to call when you're leveraging polymorphism this way. So if you're creating this use item method, maybe you want to expand this and do some other things here. Whatever you want to do with that item in here, whatever methods you want to call, make sure those methods are in the game item class, which might, as your game evolves, might mean refactoring your code a little bit. Take some methods, there's some method in the weapon class that you really want to access right here. Move that method to the game item class, have all the other classes inherit that, but then you can use that method in this method because you have an object of type, a variable of type game item, which might refer to any game item and its actual type. So whatever its actual type may be. And then when you call the use method or any other methods on it, you do still get the overridden behavior. So you do still get weapon specific behavior, health potion specific behavior when you call this use method, even though you're calling it through a variable of type game item. So this is where it becomes really handy. When you do the assignments in a local variable like that, it's not very impactful. You just get the downsides without the benefits. But when that assignment is across a method call, when you have a parameter of a super type, and then the arguments can be any of the subtypes, that's where we really get some power. And the second selling point is data structures. So when we talked about data structures, I said you create an array list of integers, it can only ever store integers. You create an array list of strings, it can only ever store strings. And that is still true, but since we know about inheritance now, our array list of game item, if we create an array list of game item, that can only ever store game items, but health potions are game items, and weapons are game items. So this one array list can store either health potions or weapons or any other class that we write in the future that extends game item. Which in this example, player actually extends game item, which I think is a little clunky. I won't really talk about that much beyond this. But an array list, this inventory for the player could actually store other players. I don't know, it gets wonky at that point. But this array list of game item, we want the player to have an inventory. You're playing a game, you want to walk around, you want to pick up items, add them to your inventory, and then be able to use those items from your inventory. It's going to be hard to do that without inheritance, or without polymorphism, because we'd have to have an array list of health potions, an array list of weapons. It's going to be awkward to have all these separate array lists and another array list every time we want to add bow and arrow, sword, etc. We'd have to keep adding more and more array lists to this class and have your potion inventory, your weapon inventory. It would get tedious. But here, we're going to create one array list of type game item, and it can store anything that extends game item. Now we can write a pickup item method, add something to our inventory, which is going to take a game item, which could be anything that extends game item, add it to that inventory, and we can call the use method is our only really useful method in the game item class. So we can call that use method on anything in our inventory. So in this case, we don't have a way, just because it'd be too much code for the slide, a way to use specific items like by index or something. But we will have, just to show the point, a method that uses every item in the inventory, iterates over everything in the inventory, and then calls the use method on all of those items. And then clears out the inventory because everything was used. Now, this is something in JavaScript and Python in 1.15. You really took this for granted that you could have an array or a list. It's awkward that those are the actual names. A list in Python, an array in JavaScript, and they could just store anything. If you create a list in Python, you put an int, a string, a double, and a dictionary in the same list, Python's like, yeah, sure, whatever, I don't care. It just lets you mix things in there all crazy. But now in Java, when we went to strongly typed, a strong typing system, we had to say, I want an array list of a specific type. And now we're finally starting to blur that a little bit. Through polymorphism, we can start getting more flexibility and functionality out of our data structures by having data structures of supertypes. So the first selling point was having methods that are coded to supertypes, or in general, any assignment where you're storing an object of one type and a variable of one of its supertypes. Following that is a relationship. And the second selling point is data structures that can have mixed types, as long as the data structure is of the super type. You can store any of the subtypes of that type in that data structure. So to bridge this over to your homework, you have songs, you have movies. They both extend rateable, meaning they can both be rated, is the naming convention there. So you can rate both of these. They both extend rateable. So you can have an array list of ratables which can have songs and movies in them mixed together. Instead of having your media library, which is the homework, the polymorphism homework is going to be, instead of having a media library with an array list of songs and an array list of movies, you're going to have one single array list of ratables and then mix songs and movies in the same array list. I'll wait on this slide for questions if there are any. That is polymorphism. Of course, we got the rest of the lecture. We're going to reinforce a lot of this stuff. But the next few slides, I'm going to clean up some topics we skipped in inheritance, namely abstract and interface. So if there are questions, I'm going to take the chance to take a sip of tea. Oh, goodness, it's getting cold. Cold tea is no good. Had to drink it before it got even colder. So any questions on that? I don't see any coming in. Has it been 20 seconds? I get too impatient to wait 20 full seconds. It's a long time to just sit here staring at my computer without watching like YouTube or something. All right, if there are questions as they come in, I'll go back and answer them. Hey, we got a question. What is the benefit of strongly typed languages over ones like Python? Oh my. So I had to try to answer this briefly because I could talk forever about this. My favorite benefit is that the compiler helps you out. Like when you run a Python program, you'll get errors like can't concatenate a expected type string got int, something like that. Usually when you try to print something to the screen and it's an int and you say as a string the value of my int is, and then plus, and then your int, and it says you can't do that, but you don't find out till you run your program. It says, hey, that's the wrong type, and the program crashes, and then you have to go back and put str in parentheses around your value. You probably came across that in 115, or anytime if you've coded Python otherwise, you've probably had that error at one point or another. With a strongly typed language, you don't get that problem because your IDE will just underline it and say, yo, this is the wrong type. And then the compiler just kind of flags you down and says, yo, I think you did something wrong here. Why don't you fix this before we run your program? Where with Python, you're only going to find that out when you run your program, or JavaScript. You only find out when you run your program that you have that issue. But with a strongly typed compiled language, you find that out as soon as you type the error. The IDE is going to be like, fix this. And you get to catch your errors much, much quicker, especially, well, since we're talking about typing specifically, especially when they're typing errors. You can't make those mistakes because the compiler won't let you. So you know that if your code compiles and runs, you're not going to see any of those types of issues because the compiler already checked for them all. You can't have typing issues. The only typing issue you can have, which a lot of you have had, is if you have null. Null is the only thing that kind of breaks that. When the compiler will say, yeah, that's fine. You have a variable of type game item, and you're calling its use method. That's perfectly valid. But if item happens to have the value null, then you're still going to get a typing error. You're going to get a null pointer exception because you have the wrong type. You don't have a type when you were supposed to have a type. So you'll still see that one, but most typing errors are checked by the compiler with a strongly typed language. Yeah, and then you got a 60-second timeout because you forgot to do it. Don't forget to do it. Just don't forget. Oh, by the way, I still forget that all the time. I run my Python programs and I'm printing out a string and I forgot to convert it to, or print out an int and I forgot to convert it to a string first. I do that all the time, as we all do. So I use that example. It's probably the most common typing issue in Python. All right. Sorry, you have to wait 60 seconds to submit again. It's I want to implement something like that for 116 as well. Some cooldown, so you can't just bash against the autograder. Students, and if you do this, that's fine. I'm not picking on you, but at some point in the future, I'd like to fix this, where students will submit and then get their feedback. It says, no, you didn't finish the thing. Change like one line of code, just basically guessing, and then submit again, and then just guess, and basically just doing a guess and check. It's not the way to learn the concepts, though. You might eventually brute force your way through the assignment, but you clearly didn't learn what you were supposed to learn from that assignment, if that's your strategy. So I would like to prevent students from doing that. Right now it's allowed because I don't have a good way to prevent it, but someday I'd like to have a good way to prevent it. And I think cooldowns would be the way to go, like an increasing cooldown. First you got to wait like 2 minutes to resubmit, and then add a minute for each submission or something like that, to the point where you have to wait a full hour sometimes to submit again. But not this semester. That won't happen this semester. It won't happen next semester either. All right. So we had this awkward situation when we talked about just inheritance. And these are inheritance concepts. I just think the inheritance lecture is already jam-packed. And the polymorphism lecture is kind of light, to be honest. We just talked about everything I want to talk about with polymorphism. And then we're going to go to a memory diagram and see it all in action. That's really all I have to say about polymorphism. So let's fill it in with a little more inheritance concepts. Yeah, anyone with 100+ submissions on any programming assignment, you're probably doing it wrong. The only reason I say probably is there are cases where one of my incorrect solutions is just really obscure, something you really haven't thought about and everything. There are cases where students know the concepts really well and just get hung up on one of my incorrect solutions. I think I have all those incorrect solutions out of there. They don't exist. The questions we're getting in Piazza and office hours are really like students who aren't testing the right way. By the way, I've been seeing a lot, just cleaning up Piazza this morning, I've seen a lot of students who are not checking their linked lists for task 5, the playlist one where you ask the tree for lists and then you have a linked list, and then just not checking the linked list, or they check just the head node and don't actually go through the whole linked list step by step to check the thing. I don't know why so many of you are just not you're effectively not finishing your tests. If you call the get list method and it gives you a linked list, you need to check that linked list to make sure it's right. Finish your tests, like make sure it's right. Don't just check the head of it or just the first two nodes. Especially when I have an incorrect solution that says can't work with lists more than 3, and you're only checking the first element. Well, the incorrect solution is going to be right for the first 3 nodes, which is why I have that test, is to make sure that you're actually testing your linked list, by the way. So the incorrect solution is effective right now. It's making sure that you're actually testing them, your linked list. And And I give you in the data structures 1 testing, the test that I give you for DS1 for tests that test task 3, like I give you an example of how to go through a linked list. Like I basically give you the code. You really just got to cut and paste that and then modify it a little bit. So I'm surprised so many of you are not doing that. It wasn't meant to be that tricky or anything. I really gave you a lot of help on that one. All right, abstract. That's plenty of time. Y'all got your questions out. There's only one question, but so abstract, which my concern, 25 people watching. My concern is that any of you watching are already up to speed on all this stuff. So let's get on with the new stuff so y'all can learn. So I gotta stop doing it, but whenever I stop to say things like that, like everyone who's actually listening probably knows all of that. It's the people who aren't listening that I have no way of reaching them. I can't teach them. I don't know. It's a frustrating thing. So we had this awkward situation when we talked about inheritance, where we had some methods, like we had to define every method. Every method had to have a definition. It had to have a body. But sometimes that body wasn't really important, or it was just really weird to use. The use method here, it used to just say system.out.println item used, which doesn't really mean anything. And then we would want to override that method with some actual functionality. And this got even worse. How many people in the course? Last I checked, there were 90. There are 94 enrolled, and last I checked, 4 resigned. So 90 left. But I haven't checked. I think last Friday was the end of the resignation deadline. So I'll have to get the final number. So, and I think 55 when I checked this morning have completed task 4. So I'm nervous for a lot of students. And yeah, 23 watching live, which a lot of students are in different time zones. And I explicitly told you all that you don't have to watch live. But I do worry, if you don't watch live, it's very easy to not watch that day. Hopefully they're watching day of at least, but I have my doubts based on the Piazza questions. Some students explicitly tell me in office hours that they didn't watch the lecture pertaining to the homework that they have questions about, and I'm always perplexed about that. Like, what is your strategy here? I don't even get that. I don't understand that. You can't do the homework if you don't even watch the lecture. So in those cases where we don't need a default behavior for a method, we have this use method, and we had default behavior because we had to at the point, but it didn't really make sense to do that. And did I mention, I think I got off track. It got even worse with the comparator class. We had the compare method implemented with a default behavior of return false. And then you just always want to override that behavior. It doesn't make sense to have some default behavior that you can optionally override when the default behavior is just return false. So sometimes we don't want a default behavior, and we just want to say, hey, there's this method, it's called use, it takes a player, and whoever extends this class, it's their responsibility to override this method. To do that, we can make it an abstract method. So an abstract method is a method that only has the signature, so name, parameter list, including types, and return type, and then we just close it off with a semicolon. We say this method will exist at some point, but it don't quite exist now, or at least it doesn't have a definition. So we call declaring a method without defining the method. So we declare that this method will exist, but we don't give it any body. We don't give it any definition. It can't be called quite yet in its current form because the method doesn't exist fully. It's not fully defined. So if you have even one abstract method in your class must also be abstract using the abstract keyword. And the big thing about abstract classes is they cannot be instantiated. So once you have an abstract class, once game item moves to abstract, You cannot say new game item of, X, Y, some two doubles. You cannot create an object of type game item if game item is an abstract class. You cannot create instances of abstract classes, which is usually something you don't want to do. I don't want to create an object of type game item because, what is that item? I want to create health potions. I want to create weapons. I want to create concrete things, not this abstract game item. It doesn't make sense for me to have a game item object, an object of that type. So this actually is useful even if you don't have any abstract methods. Or at least I'll do this. Even if I don't have any abstract methods, sometimes I'll make my class abstract to say, don't create objects of this type. This class is only made to be extended, and then you can create objects of those types that extend this class. So game item, just like it was being used, this is the way it was being used already, but it's only made for inheritance. You have this game item abstract class. Its only purpose in life, its only purpose to exist, its only reason for being is to be extended. And then anything that extends this, if you have something that extends game item, you have a contract to sign. You're going to sign a contract that says, I will implement all abstract methods. So game item, or weapon is going to extend game item, and game item is going to say, okay, you can extend me, but guess what? I got an abstract method. You have to override this use method that takes a player and returns void, or else you won't work. And you'll get compiler errors, unimplemented abstract method. You're going to get those errors and you can't run your code. Unless the only exception here is if the extending class is itself also abstract. So if I make the weapon class abstract and then don't implement the use method, and then I have that weapon class which is made to be extended, and it's going to be extended by swords, bow and arrow, rocket launchers, grenades, and then they all implement the use method, that would be the only out, is to be abstract itself if an extending inheriting class doesn't implement the abstract method. So there's a contract. Eventually the abstract method must be defined if you're going to be what's called a concrete class, which is just a class. Every class we've seen so far until these two slides have been concrete classes, meaning you can instantiate them. So why would we bother? Again, why would we say, here's a method, it'll be implemented later on? Well, this is kind of our cheat code to getting around the restriction of polymorphism. So polymorphism, I have an object stored in a variable of type game item, I can only call methods known to the game item class. But nowhere in there did we say those methods have to be implemented. So if we have a method that we want everything that extends game item to have, and we know we're going to want to call that method through variables of type game item, but the game item class doesn't have any specific default behavior that it wants to give that is inherited and then just using the superclass method. If we don't have any clear default behavior, we'll just make that method abstract. So now the use method, even though it's not defined here at all, the use method can be called through variables of type game item. So when we have a method of type that takes a parameter of type game item, we can now call the use method, even though game item doesn't know what the use method does at all. Only the concrete classes that extend game item know what this method does for objects of those types. It doesn't matter because game item still is aware that the method exists and that any concrete object that exists on the heap that is a game item must have at some point implemented the use method. So we get that guarantee by having this abstract method. So that's the advantage. That's the reason we would use abstract methods. To make sure that the method exists, then we can call that method through variables of that type, even though we don't know what the method does. And we can go one step further with this and create what's called an interface So that was abstract classes. Abstract class is a class with at least one abstract method. An interface is effectively a class, but it has only abstract methods. Only abstract methods. And that's it. And when I say only abstract methods, I mean only abstract methods. Well, kinda. There's a few caveats if you want to get really technical. So an interface can have only abstract methods. And this is what makes sense for our comparator. Our comparator only had one method, and it makes sense for that method to be abstract. So we're going to create this comparator as an interface instead of as a class that we had before, or an abstract class, because we can go all the way to interface. If you can go all the way to interface, you generally want to, for a reason that will be on the next slide. And it just has one abstract method. Now we don't have that default behavior of compare, which just returns false, which was really clunky and awkward. And then you just said, hey, look, int decreasing, you don't have to override compare, because technically it has a full definition, but you really should. Now with compare being abstract, the compiler is going to make sure that anybody writing a class that implements comparator, they have to implement the compare method. They have no choice, because there is no default definition. There's no default behavior for this. So now they're forced to. And when I say only abstract methods, no instance variables, no constructor, no methods at all with definitions, no constructor, even an abstract constructor is a concept that doesn't quite make sense. No constructors at all, no methods, no non-abstract methods, no instance variables, nothing. You can't have anything else in here, in these classes. And then when you extend, or I guess that is the wrong word, when you implement, oh, that's the wrong word, when you inherit, when you inherit an interface, instead of using the extends keyword, we use the implements keyword. I had the 3 words in there, but I have them all mixed up the first go. So when you want to inherit from an interface, you use the keyword implements instead of extends. So int decreasing implements the comparator interface with the type parameter, the generic type being integer in place of t here. So you aren't inheriting necessarily any state and behavior. You're implementing the abstract methods that come with that interface. And then we can override compare to do what we actually want it to do. And then there's a few implications apparent in interface. Since every method has to be abstract, you don't have to use the abstract keyword. And every method has to be public, so you don't have to use the public keyword either for your interface. Do I mention the caveat? I probably should, since I kind of mentioned it. So you can override methods in an abstract class? Yeah, sure. Mm-hmm. I'm not sure exactly what you mean by that, but any way that I could think you could mean that, the answer is still going to be yes. So if you have an abstract class, like the game item class does inherit toString from object, you can override toString inside the abstract class. And then all inheriting methods will get that overridden toString method. Just like we did with classes, that's still legal in abstract classes. The only difference is you can't create instances of that abstract class directly. If you mean inheriting classes can override the methods from the abstract class, also yes, you can do that too. So I should mention this caveat just because I kind of mention it. If you want to get really technical, you can have something that's not an abstract method. You can have, I got to remember them all. Public, final, static variables. Public, final, static variables. So you can have static variables. Actually, you could probably have static methods. I haven't really tried it, but there's no real good reason to. Maybe there's some situation where it makes sense, but you can have them. So you can write something that looks like an instance variable here in your interfaces, but it's not an instance variable It's a static variable, meaning it belongs to the class itself, and those variables have to be final and they have to be public. And just like how you don't have to write public abstract right here, if you just write something that looks like an instance variable, it is implicitly public, final, and static without writing those keywords. So it does look like at first glance that you can add instance variables to an interface, but you cannot. It's just invisible that those are static variables. Say in a class that is an extension of the abstract class, can you override a method that was originally in the abstract class? Yeah, yep, you can still do that too. So just like we were overriding, when they were all classes and not abstract classes, and we were overriding methods, same exact thing applies in an abstract class. So an abstract class can have concrete methods that are not abstract. They can have non-abstract methods and abstract methods, and either one can be overridden by the inheriting classes. Okay, why would we use interfaces? This seems silly. Just make them abstract classes. We already have that functionality. So you can only extend one class. That's a restriction of Java. Java says you can extend one class and one class only. It can either be a class or an abstract class, but you can only extend one class. But you can implement as many, knock yourself out. But you can only extend one class. So if you want to implement multiple interfaces, you would say implements and then a comma-separated list of all the interfaces that you're implementing. And you could say public class int decreasing extends a class and then implements any number of interfaces. So if you can make your abstract class an interface, you want to lean towards that. Make it an interface and allow yourself to implement multiple interfaces, because you might have a class that already extends another class, but you also want it to implement your interface. Make that an interface instead of an abstract class to allow that. If an abstract class inherits an interface, you do not have to implement all the methods. But once you have a concrete class, so as soon as you say class something with no abstract, not an interface, a concrete class, you're saying this is something that can be instantiated. You can say new int decreasing. At that point, any abstract methods that were inherited, either directly or indirectly, so if it extends a class that implements comparator, it gets handed, int decreasing will inherit the abstract compare method that it would have to implement. But the abstract classes do not have to do that. Because they can't be instantiated anyway, they're allowed to have abstract methods, so everything's fine. If an abstract method, an abstract class could extend another abstract class or implement an interface, or both, and not even touch any of the abstract methods that it's responsible for, just forward that responsibility to anything that's going to extend it, and then that first time something's like class extends that thing with all the abstract stuff, its responsibility is to implement them all. Okay, that's a big lecture. Well, I did get a little off track, but not 13 minutes off track. That's a big lecture for the fall or spring. I might have to trim that one down. But the other two this week are small, so the week overall is fine. So we're fine for the summer. All right. Let's look at some code. So let's hang out in IntelliJ for a little bit before we head over to the memory diagram. And then if we have more time after the memory diagram, we'll head back to IntelliJ and do some more live coding. And I can make my face bigger. I'm not going to use the whole corner of the code. Should I make the font bigger? Let's do it. Settings. Let's go 20. I knew that. I knew that. I always make that mistake. You gotta go to editor. Font. Why there's not just one font setting that changes the size of everything, I'll never know, but it's the way it is. All right, so we're going to revisit some week 6 code. I have it set up for my starting point in the starting point package to talk about how we could change the week 6 code to become to leverage polymorphism. So I have the game item class, and this is mostly in the state that we've seen in week 6. Even though we saw some of the changes already in the slides, I want to show how exactly we got there. So this is mostly in the shape it was in week 6. Now in the slides for week 6, we didn't, or lecture 6, I suppose, to be more accurate, we didn't see everything all together in one place. So let me just go through the code and just refresh on what everything is in these classes. So we had a public class game item, X location, Y location, and a constructor to set those things, a couple of getters, and this move method, which we talked about a little bit in the slides. It popped up at one time to say we can add this method, and now all extending classes get the move method. Here it is in action, not in action, but here it is in the code. And we had a toString method that we overrode, and this use method that takes a player. In week 6, we had the use method that didn't take any parameters. So this is a little bit different. We're going to have it take a player, so we can have the use method actually do something. Health potion extends game item. It adds an instance variable increase, has a constructor that takes 3 parameters, calls the super constructor, and sets its own instance variable. Has a use method, which is overridden. I'm going to add my annotation. I had it set up like this because I wanted to show with and without the override annotation. It still works just the same. Now it's bugging me. I want my override annotation there. So we're overriding the use method that we inherited from game item, and we're taking that reference to a player, calling its take damage method. Oh, I forgot it was set up like this. I want to change this, but call its take damage with a negative value, so it'll increase its. Oh, I don't like that setup, but anyway, we're gonna call it take damage with negative increase, where increases the amount of healing that a health potion will do. And a getter for increase, which we're not using. And then overriding the toString, we saw this last time. We're calling the superclass toString, so we're calling game items toString method and then adding extra stuff to it, and that's what we're returning in our toString. We have the weapon class extends game item, overrides the use method to set the player's damage dealt. And actually, I want to delete this for now, just so I can show an error that'll come up. It has a constructor. It's going to set damage just like same setup as health potion. And then a toString, which again, I'm going to add my annotation to make it clear. Not calling the superclass toString and just strictly printing out weapon-specific stuff. And then what I didn't really show too much in the slides, we have the player class, which I think it's awkward. Can I change this right now? I think it's awkward to have it extend game item. I'm going to just not have it extend game item for this walkthrough. But it has max HP damage dealt. We're going to initialize max HP and HP. And then damage dealt, we're going to hard code to 4 as the initial damage dealt. Getters, set damage dealt, which is going to be used in our weapon class. Our weapon, when you use a weapon, we're going to kind of say that equips the weapon and that the player is going to have that extra damage dealt. And a toString method, which prints out, its health as a, HP over max HP. And then also call the super toString, which we're going to remove because that's now the object toString, which we don't want. And then take damage, which is going to subtract health. We don't have our check. So one of the reasons why I don't like this right here, it's not self-commenting code for one. That taking damage to heal is just really, really bad documentation. This is a case where I'd either want to fix the code or actually add a comment calling this with a negative, to do an increase of health. But take damage implies that this method should be decreasing damage, which means that it doesn't make sense for this method to have a check to make sure you didn't go over max HP. But when you're healing a player, you want that check to make sure that you didn't increase beyond your max HP. A take damage method wouldn't make sense to have that check. It would make more sense for this to say if damage less than 0, you know, do nothing, else do the thing. It would make more sense to me to do this. You know what? Let's do a little bit of refactoring. We got enough time in this lecture. So I want to set HP method. We're just going to say if, don't like that being capital. This dot HP equals HP. I suppose that's fine. And then if this dot HP greater than this dot max HP, this dot HP equals this dot max HP. So in the setter, we can have that check. And then since it's a setter, we might want to look at negatives. If HP is less than or equal to 0, do whatever is supposed to be done when a player dies. But let's leave it like this for now. And then health potion can say set HP to player dot get HP plus this dot increase. I think the reason we had it set up the other way is because when we do the memory diagram, this is two stack frames, and it just gets more cluttered on the memory diagram. So I believe that's why we had it set up, but I would rather have it a little more like this. Okay, so let's get on to what we want to do. So the big thing is this use method just by default does nothing. So it doesn't make sense to have this default does nothing method. So let's make this abstract. Oh, just to show. Let's make this abstract. I think the error is going to be I can't do this in a non-abstract class. Abstract method in a non-abstract class, that should absolutely be an error. So let's go to our class, make it abstract. Oh my goodness, abstract. Okay. And now we have our abstract method in our abstract class. So this is going to cause some issues. So let's go through our code and say, okay, we have this abstract method, this abstract class. We can no longer, by the way, create a new game item. Game item is abstract, cannot be instantiated. Can't instantiate an abstract class, but if we made this not abstract, add our empty body again, got rid of abstract here, change it back to a class. This is legal. Not really what you want to do. You don't want to create a new game item. That's not what you want to do. But it is legal. But once it's abstract, not legal, which is, I think, a good thing here. We don't want to allow anybody to just say new game item. No, create a new weapon, create a new player, create these actual tangible things, not an abstract game item. So we can't create an instance of an abstract class. Let's go through the rest of our code and see what implications we have. Health potion extends game item. And game item, health potion does override that use method. It takes a player and returns void and has an implementation for it. So this is perfectly fine. Health potion inherited an abstract method and it implemented that method. So everything's perfectly fine here. Nothing to complain about. When we go to the weapon class, we're going to get an error here. So weapon extends game item. Game item is an abstract class with an abstract method use that takes a player and returns void. Weapon did not implement that method, so my error is going to say, implement that method. What the hell are you doing? Weapon must either be declared abstract or implement the abstract method use of player in game item. So I could just make this abstract and the error does go away. But now, guess what I can't do? I can't create a new weapon anymore. because weapons abstract. I can't create weapons now. Now, this might be what I want to do if I want to extend weapon with sword, bow, and arrow, like I said earlier. Maybe I do want weapon to be abstract. It doesn't really make sense to have an object of type weapon, even though that's what we're doing here. It doesn't really make sense to do that. I want a specific type of weapon. But regardless, I always think of these weapons as swords, for what it's worth. We're going to make this non-abstract. And we're going to override public void use that takes a player. Now we've satisfied the condition. We've implemented the method. We haven't had to do anything yet. And now we're able to instantiate weapon because it's not abstract. Everything's fine now because we implemented the abstract method. Let me... Oh, did I miss that chat? Concrete class need to implement all the abstract methods they inherit. Yep. Okay. I kind of missed that one, but I did mention that in answering your other question, I believe. So let's implement the use method. Player dot set damage dealt to this dot damage. So when a player uses a weapon, we're going to set that player's damage dealt to this dot damage. Why is that lowercase? Okay, but that's only half of it. Let's we have methods. No, we didn't use polymorphism yet. That's not even half of it. So that's just setting up inheritance. Now, in the player class, I'm not even using take damage anymore. That's fine. In the player class, I want to set up some inventory. Private array list of game item. So now a player can have... And I'm going to initialize it just in line right here. Inventory. So I want an inventory object so a player can pick up any number of items. I'm going to, just to get it all on screen, I'm going to put it right here. My public pickup item. We're just going to take a game item. We're going to return void item, and then this dot inventory dot add item. So whether item is, let me clean this up a little bit. Don't need this. I don't want the toString either. Just so I can get these on the same screen. Can I get there? Maybe I shouldn't have made the font bigger. Let's create a main method. Just to test this out, I'm not going to do like formal testing or anything. But create a player equals new player. What's the player constructor? Just max HP. We'll say 50. Player dot set HP to 20. We'll have them take some damage. And then player dot pick up item, new health potion of 25. I gotta give it a location. So they're gonna pick up a health potion that heals 25, and pick up another health potion which will heal, let's say, 12. So 25. So that should put them over 50. So we're gonna check, make sure our max HP is kicking in, and then player dot pick up item, new weapon. We'll put this at, I don't know, 0, 0. Location doesn't matter for what we're doing right here. And then we'll set their damage to 1,000. And then, I don't know, we'll print out the player. I deleted their toString method, but I want this just so I can set a breakpoint here. So this is the usage that we want. Pickup item takes a variable of type game item, and we're giving it health potions and weapons. Those both extend game item, so those are valid calls. And inventory will then have two health potions and a weapon. And let's call player.use all items. That we saw in the slides. Doesn't matter if it's private or public for this example, but it would be made to be called by other classes, so let's make it public. And this will go through the inventory for game item in this inventory item.use of this. This inventory clear keeps the, so in the slides I had it set to a new array list. This I'll call clear, which I believe removes all elements from the list. List will be empty after it returns. So just doing it a different way. It'll preserve that array list on the heap instead of creating a new one and replacing and having it be garbage collected. Doesn't really make a difference for what we're talking about, but I just felt like doing it a different way. So we have a data structure that can store multiple different types. We have a method that can take multiple different types. Then we have a method that's going to iterate over those items in the inventory and then have it use each item, call a method on objects of type game item, and then have them call the method that pertains to that object. And I want to see this in action. I'm going to set a breakpoint here and use the debugger so we can see if this actually is going to do what it's supposed to do. I deleted the toString method, so this isn't really going to help us out. But let's run this in the debugger, and we can use the debugger to show all of the information that we need. So let's run this. Compiling. And at this point, we expect the player to have an inventory of 2 health potions and a weapon. So this array list of type game item is currently storing a health potion that's at 776 on the heap with these properties, at 77.7 another health potion with these properties, a weapon at 778 with these properties, and we can have all those in the same data structure. And if we step into this use all items method, this is a reference to that player with that inventory, just like we would expect. And then we're going to iterate through the inventory one item at a time. So item is now the health potion with increase of 25. We're going to use that item. So even though this is in a variable of type game item, item is in fact a health potion. So when we call use, we're going to the health potion class. We're going to the health potion class to find the use method, and we find it right here. Just like we did with inheritance, we're looking at the type of the object to find where to go in the code to find out what method to be called. We're doing the same exact thing, but now the variable type doesn't have to match the object type. Which, if you were always using the memory diagram like I showed in lecture, you're going to the object, looking at the type of the object, and then going to that class. Then, honestly, there's not even anything new to do with your memory diagrams. Just don't watch the variable type. That only determines whether the method is a legal call or not what method actually gets called or what happens when that method gets called. That's all the object type. And then set HP, we're going to do go into our getter, go into our setter, make sure we didn't go over the max HP. And after using that item, this .hp is 45. We were successfully healed by consuming that health potion. We're going to consume the next health potion that heals us 12. Go into the health potion method. We're going to end up setting our HP to 57. Our conditional should kick in. Set our HP to 50. And after that call, our HP is maxed out at 50. So our code's doing what we wanted to do. Feeling good about that. Go to our next item, our weapon, with damage 1000. Now when use is called, we end up in the weapon class because the object is of type weapon. We're going to set damage dealt to 1000. And after that item is used, this player's damage dealt is 1000. Then clear the inventory. So after all that, inventory is empty. Damage dealt is 1000. HP is maxed out. This player is ready for battle, ready to go attack whatever thing they're going to do next. When we print player to the screen, since we didn't override 2-string, actually we have the inherited 2-string, don't we? No, we don't. Oh, no, because I got rid of the inheritance in player. Player extends object and doesn't override 2-string. So we get the object 2-string, that default 2-string, which is almost always useless to us. But the fully qualified name of the class, the package, and then the class name, and then at some random hex value. Okay. Let's shift gears a bit, but let's keep cruising on. I have another example set up. We have this comparator class, which just returned false. We had to have some default behavior. If we made this abstract, we get errors. We can't do this unless the class is abstract. So we could do this. That's fine. Missing method body or declare. Oh, I didn't actually put abstract here. But we want to go a step further than that. We want to create this as an interface. And you notice these two keywords go gray right away. It's because they're optional. It said, look, you got an interface here. I know your methods are going to be abstract. I know they're going to be public. You really don't need to tell me that it's a public abstract method. So let's just get rid of all that. We don't need our comment anymore. Our code is more self-commenting. We don't need the comment to say always returns false because it doesn't do that anymore. It doesn't do the dumb thing of returning false by default. And just because I mentioned it, if I have like double x equals 7 here, that looks like an instance variable, doesn't it? It really looks like an instance variable. But if I write public final static here, also notice that all of these are grayed out. Static, that's redundant. It has to be static. Final, that's redundant. It has to be final. Public, that's redundant. It has to be public. So even though none of those keywords have to be there, this is always going to be a public final static variable if it's a variable inside an interface. You can't have any other type of variable. You can't have instance variables. You can't even have static variables that aren't final, where final is the same as const in JavaScript. It means that the value cannot change. We can never say x equals 6 later on. Cannot change. And just because it came up, and I'm a little curious, to be honest, let's see if we can have public public void. I can't even think of anything. But let's just have a method that does nothing, I guess. And I just want to know if I can have a static method. Okay, so you can have static methods in interfaces as well. So it looks like that's legal. We can do that. They have to be public, so public is grayed out. But we can have static methods in interfaces, so I guess that's good to know. I don't know why you would really want to do that. You can put your static methods anywhere else. It'd be fine. And then when we get to int decreasing, instead of extends, implements, everything else is the same. We're just implementing an interface instead of extending a class. And then insertion sort and in our BSTs, our binary search trees, we actually did use a method that takes a comparator and then we would give it like int decreasing. This was legal because int decreasing, it now implements comparator of integer. It used to extend comparator of integer. So this is a valid call to say new insertion sort of int decreasing, new int decreasing was legal because it is a comparator of t if we have an insertion sort of integers that is a comparator of integer. And one last thing while we're in IntelliJ, I'm just going to borrow the ArrayList class for this instead of setting up my own example. But ArrayList extends one single abstract class, an abstract list, which is an abstract class that also extends and implements things for what it's worth. But ArrayList extends one class, so it can't extend any other class, but it can implement as many interfaces as it wants, and it happens to implement 4 separate interfaces. If we look at all these interfaces, these are interfaces which can extend. Oh, I forgot about this. You do use the keyword extends if it's an interface extending another interface. So here's another interface which extends another interface. So the list interface extends from 2 other interfaces, but it's not allowed to implement any methods. It can only have abstract methods. So it inherits abstract methods, then adds more abstract methods onto it. And then when it gets to ArrayList, since this is not abstract, it's responsible for implementing all of those methods, all those abstract methods from all of these interfaces and any abstract methods in the abstract list interface, which I think extends the list interface, if I'm not mistaken, or implements the list interface. So it implements that same interface multiple times through multiple different avenues. So it definitely has to implement all the list stuff. And then it does, of course. It implements every method in all of those interfaces because it has to. And the advantage of that, do I take this? I think I'll take this one step further. So in our, I erased one extra thing. So in our sorter here, we take an array list and then sort an array list. We can sort it an array list of any type with any comparator. So we have a lot of flexibility. But Java will take this a step further. Oh, I forgot it uses this syntax. But it'll take anything that implements the list interface and sort it. So as long as, yeah, I don't feel like going into this syntax. This means anything that extends E, or anything that implements E. But they go a step further. They say we're not going to write a sorting method for array lists, a sorting method for linked lists. No, we're just going to write a sorting method for the list interface. And as long as you implement the methods in the list interface, we can sort it. So it goes even more powerful than our method here, which we could just, honestly, we could just we don't use anything that's array list specific, so we can just use the list interface. And then when we want to sort, the return type is now list. Then when we want to sort, we would just use it the same way. Array list implements list, so we can use our array list as a list. And now our sorting method is as flexible as Java's built-in sorting method. So it doesn't take much work to make that change. We can change this to list. Duplicate code fragment. That's fine. All right. I think we're good in IntelliJ. That was a lot. So if there's anything there that was a bit much, by all means, let me know. I'll be happy to go back to IntelliJ. I'm not going to wait the 20 seconds, so I am going to boot up the next set of slides. And we should, by the way, this is only 15 slides remaining. We should have some extra time at the end if you have questions about anything. Especially with things heating up with the course. I would assume there's questions that aren't necessarily related to the lecture at hand. I'd be happy to take some of those until 1:30. Then I gotta get ready for office hours. Alright, where I'll definitely get questions about homework. So, to review, polymorphism, whenever you have an object of one type being stored in a variable of another type, you are leveraging polymorphism. There's no other way to do that. You're leveraging polymorphism. And if an object is a type, meaning it inherits from any type, either directly or indirectly, it can be stored in variables of that type. That is polymorphism. So these slides are going to be a big old memory diagram, and it's going to be this code. So let's stare at this code for a little bit, get ready for what's going to happen. This is mostly code that we've seen in the previous slides and that we just messed with in IntelliJ. I tried to remember exactly how I had this one set up. I think it's a little bit different. We have the usable interface, which I didn't have before, so we'll talk about that. But we want to go through this code in a memory diagram. So we have a main method that's going to create a player, which is going to have an inventory of usables. And we did this so we get extends and implements in the same line, by the way. This is a little bit extra complexity that we wouldn't have normally, but just to have implements and extends in the same line. Use all items that we saw, pick up, which is going to take usable, so usable instead of game item, and then some getters and setters. Our usable interface just has that use of player method, so instead of putting that in the game item class, we're breaking that off into its own interface for usable, and then game item would still take care of all the location based values. I trimmed it down to one double just because this one was really hard to fit on the on one slide, and when we do the memory diagram I will have to swap code in and out as we go, so this is the only time we're going to see all of the code at one time. Even with as much trimming down as I did. So our weapon class is going to extend game item and implement usable. So it gets the state and behavior from game item, which is really just this instance variable in the constructor, and then it's going to get the abstract method from usable, so it's responsible for implementing the use method. There's no option here. We can't just take whatever we inherited from usable because there's nothing to inherit, there's no definition. All we inherit is the responsibility to implement the use method. So we're going to override that use method to get the behavior that we want, and add this damage variable and our getter for damage. Potion likewise extends game item and implements usable, so we have to call the super constructor. And then override use, we have to override use. There's no other option. And we're going to say our potions always heal 20. Again, I wanted to get rid of instance variables. This memory diagram gets cluttered quick. I had to trim as much as I could to make it work in slide form. So we're going to create weapon and health potion. Don't forget your super constructor calls. Pick up the weapon and health potion, then use all the items. So very similar to what we saw in the debugger just now. Hopefully we hit this from enough angles that it makes sense by the end. Hit in slides, hit you with the debugger, hit you with a memory diagram, which, a reminder, memory diagrams show the same information that the debugger is going to show. So you can always use the debugger to test your memory diagram understanding. That's a great way to practice. I would write some code or take some code in the repo, draw out my memory diagram that I think it's going to be, then run the debugger and see if I can see all of the same information in the debugger that I wrote in my memory diagram. A very, very good way to practice. All right. So this starts off simple enough. The first three lines, we've seen constructor calls plenty of times. So just a few things that I want to point out as we go through these constructor calls. The player class does create a new array list. So in the player constructor, when it's being constructed, we're also creating a new array list and getting a reference to that array list. Array list is internal to Java, so we don't bother drawing the stack frame for its constructor, but technically it is there. It does get created. Oh yeah, I forgot the default. I won't put this on the quiz, but player doesn't have any constructor, so the default constructor is used. That's another thing I did to save room on the slide. But no explicit constructor, so we do still get a constructor call, but it's the default constructor, takes no parameters, and has no code. Doesn't do anything. And then creating a new weapon and potion. Don't forget your super constructor calls. Don't forget all your parameters. Don't forget your instance variables. This is all review. The one thing to kind of point out, I feel like I said a lot this lecture already, so hopefully everybody's on board with this, but we do create a new potion class. The constructor, the right-hand side of the equal sign, doesn't care what's on the left-hand side. This behaves exactly as you would expect it to, even if this were potion instead of usable. So new potion, potion constructor, game item constructor, potion is created on the heap. We make up a reference for it. Oh no. I'm blocking things. I'm gonna put myself right here. So the two constructors, the object on the heap, instance variable, we only have one here, just the location that was inherited from game item. All that works just the same, and then it happens to be stored in this variable potion, which is of type usable. The type of the variables, we've never even put them in our memory diagram because they really don't have an effect on our memory diagram at all. The type of the variable determines whether the code is valid, whether it will compile. For your memory diagrams on your quizzes, the code will compile. That's my guarantee to you. If it ever doesn't compile, that just means I made a mistake, and you should still do your best to come up with whatever memory diagram would happen if it did compile. I'm never expecting the answer to a quiz to be trick question, this doesn't compile. I won't do that to you. I would only do that on accident, and it's been a long time since I made a mistake like that. So even though the variable is of type usable, that just determines whether the code is valid, whether the compiler will compile the code. So usable is going to tell us whenever we use potion, is that a valid call or not? Once any method is called on this potion, what matters is the actual object type on the heap. That's why we do always write these types, because that's critically important. The interface does not have a constructor. Interfaces cannot have constructors. So there's no constructor stack frame to put on the stack for interfaces. There shouldn't be any usable constructor on the stack. There is no constructor for an interface. There are constructors for abstract classes, even if they're implicit. This one is explicit and explicitly called. But even if that, but for an interface, even if that wasn't the case, there would be the default constructor, which is still called. Not true for interfaces. Interfaces do not have constructors, so how the hell are you going to have a constructor stack frame for a constructor that doesn't exist? It's much different than the default constructor. If we don't have an explicit constructor, we get the default constructor, no parameters, and doesn't do anything. For an interface, it actually can't have any constructor, not even the default constructor, so no interface stack frames for interface constructors. So we don't put usable on the stack. That doesn't work like that. No constructor for interfaces. All right, so since weapon is stored in a variable type weapon, we can do any weapon thing we want through this variable, but potion is stored in a variable called usable. So the only thing we can do with this potion here is call use on it. Or what we're actually going to do here is call a method that takes a usable and pass that as a usable, but we can only do usable things with it. We don't have any other functionality, which for this, since I cut so much, there isn't even anything in there. I guess the location variable, I don't even have a getter for it. So, but all we can do is call use, which is the only thing that player can actually do anyway, even if it's, or potion can do, even if it was stored in a variable type potion. So I cut so much that it's the same as storing this in a potion, but it is what it is. All right. So what happens when we call pickup? We're going to call pickup with weapon. Weapon is OX480. So pickup is called through player. Player is 350. So this is 350. The parameter or the argument is stored in the parameter, which is 480. And then we're going to add that to our inventory. So pickup inside the stack frame, this dot inventory dot add of 480. Add that to the array list. Then same thing for the next pickup. Pickup this dot inventory dot add of item. Item is 120. Add that to the next available index. Can different items added to game item have the same location? And can two potions have the same location? Yes. Just because in this code I don't have any protection for that. So yeah, they can have the same location. We could code that. You know, if we built out this whole game, we might not want that to be the case, but we'd have to write that code somewhere else for them to not be able to occupy the same location. For that, we might want to write a whole physics engine with collisions and everything, and get behavior like that. The code as it is now, yeah, they can all be at the same location. All right. And then use all items. So this is getting into the bits that we really want to talk about, kind of the new stuff. The pickup item, I mean, it's new, but when you can assume that the code compiles, there's really nothing new to look at. It takes a usable. We gave it a weapon, but that's perfectly cool because weapon implements usable. So it is a usable, and it's a valid call. Now when we get to use all items, this is the calling reference to the calling object, which is player in this case, which is 350. Use all items, we're going to iterate over the inventory. So this dot inventory, we're going to iterate over everything in this array list and store them in variable named item. And then we're going to call item.use of this. Okay. Here's the new stuff, which isn't too new, but I want to reinforce it. Is item.use what use method gets called. So, and we can only call use because that's the only method in the usable interface. It only has a use method. So use is the only method we can possibly call from this variable. It's the only thing in the interface. And we're in a variable of the type of the interface. I mean, yeah, we could call toString and equals, but the only extra method we have is use. It's the only thing we can call. But we can call it because the interface does declare that method, even though it doesn't define it. But which one gets called? So since 480 use all, I'm missing an arrow here. There should be another arrow right here. Item.use. So item.use, we're calling it from an object of type weapon. So I don't even care that the variable it's being called from is of type usable. That does not come into play when you're deciding which method is going to be called. I do not care. The only reason I care that this is a variable of type usable is to check if this line compiles. Usable has a method named use that takes a reference to a player, so it compiles. Everything's fine. But now to figure out which method is called, It's always by the type of the calling object. We found a weapon. We called this method through an object of type weapon. We go to the weapon class. We look for a method named use that takes a player and go through the same exact progressions that we had before when we were just talking about inheritance. So weapon has a method named use that takes a player. So we found the method to be called. If we didn't find it here, we would go to the superclass. We would go to game item and check if there's an implementation there. There's no need to go to the interface because the interface can't have concrete methods, only abstract methods, so we're not going to find it in an interface, but we might find it in the superclass. So we'd go to game item, go through those same progressions that we did before. But we know the method has to exist somewhere because this code compiled. So let's look in the weapon class and we find it. We look in the class matching the type of the object on the heap. We find it and then we call it. We call set damage, this dot damage, player. Let me back up one because this does trip students up quite a bit. Use all items. We did item.use of this. This in that stack frame was OX350. So when we call the use method, the parameter player is this in the other stack frame. This was 350, so player is 350. And then this is a reference to the calling object, which was item, which was 480. So this is 480 and player is 350. And then player dot set damage, we're calling set damage from the player, this player object of type player. We look in the player class for set damage. We find it right here. This dot damage, this was the calling object. Damage was this dot damage in this stack frame, so this dot damage 15. This dot damage equals 15, equals damage, which is 15. So we've increased the damage output of this player. Then likewise, we get to the next iteration. It's bugging me, I missed my arrow right here. We get to the next iteration. Use item is going to the next value in the array list, 120. Gets that value. And then item.use of this. Item.use, we're calling it from this object. So this is going to be a reference to the calling object. We pass this from this stack frame, which was 350, as the player, and we look in the potion class for an implementation of the use method. We go to the potion class, we find the use method right here, and this is the method that's called. We call player.getHP. I think we're good on getters and setters at this point. Get HP, set HP to whatever we got plus 20. We got 50 from the HP. Now we got 70. We're going to set the HP, this dot HP equals 70. But which method was called always depended on the type of the object on the heap. Nothing else. And the program ends. And that's the end of our memory diagram. We actually, for the first time all semester, have a little bit of breathing room here at the end of a lecture. I think I spent a lot more time in IntelliJ last semester. But what I want to do with this time, if there are any questions, of course, I can go in any other route. But I want to go over test 7 homework so we know how we're going to use polymorphism. So for this one, you're going to add to your homework, your test 6 stuff. You're going to take those 2 methods that you wrote, which read files, and you're going to read a third file, which has movie ratings added to that. So the songs file from test 6 already had ratings associated with them. Now we're adding ratings to the movies because that movies.csv did not have ratings. So we're going to create this, read this movie ratings file. I'm not going to show you. It's title, reviewer ID, rating is the CSV format. and you'll want to add all of those reviews to your movies that have already been read. So you're going to read the movies.csv file, and then take that array list that's returned, and then read this ratings file and add all the ratings to those existing movies. So what you'll have are songs and movies in both with ratings associated with them. And then what we want to do for this homework is create a media library class. This one is everything I just explained. You're going to read that, and it gives the specifics of all of what that entails in more detail. What we're building up to is this media library class, which is going to take our songs and movies, combine them into one media library, and then be able to tell us things like what are the top K pieces of media, I guess. I call them ratables here because that's the interface that they're extending, or implementing. But things which could be thousands of ratings. If you're using the raw files, I forget, but it's you know what? Let's download it and remember. In downloads, WordPad. I think WordPad has line numbers for me. Does it not? Those all the options I get? Give me line numbers. Oh, and that's the default forever. Open with. Oh my goodness. Open with. Pretty sure Notepad doesn't give me line numbers. Oh my. It's a pretty simple feature. Alright, we're just gonna have to use IntelliJ. IntelliJ doesn't like large files like this, just so you know. It's gonna use all of my CPU just to paste text. I shouldn't have done it in a Java file. Oh shit. My fan's spinning up immediately. Let me paste it. Alright. So over 24,000 ratings are in this. So this is the title of the movie, the reviewer ID number, and then which you'll handle as a string, and then the rating from that reviewer. And you have lots of ratings for lots of movies. So we want to handle all this data. I want to get this out of my IntelliJ. So we want to handle all this data, and same thing for the songs. Do I have that in? No, I don't. Same thing for the songs, but you've already been, hopefully at least, working on that with Task 6 and are familiar with that format. So you have songs and movies with all kinds of ratings, and we want to find out what the top ratables are by Bayesian average. We're going to have 2 extra ratings of value 3 and get our top 10 lists, which will be a mix of movies and songs that have been added to your media library. So that's what we want to build here. We're going to read all 3 of those files, get all this data jammed in the media library. And the idea here, just in case it's not explicit enough, is that you're going to have your media library class with one instance variable that's an array list, or I'll say data structure, a data structure of ratables. And since movie and song both extend ratable, you can store movies and songs both in that array list of ratables. You can mix these types in your data structure leveraging polymorphism. And that's what we want. And then no, I don't really have another thing to say about it. I assume they have unique titles. Yeah. That's it. So we really want to get the top K So think of this as like a top 10 list. If your argument is 10, and get the top 10 ratables, whether they're songs or movies, and a mix of them all. Yeah, for the first time all semester, I might be out of stuff that I really need to explain to you. I think we covered everything that I need you to know about polymorphism. You definitely have everything you need to do that homework. Maybe it'd be beneficial to go through the other tasks. I didn't really get to give every task a proper introduction. So for task 6, so let me do that. Let me just go backwards, at least to task 5. I think I covered task 5 a bit. Let me. I know I didn't really introduce task 6 because I had to rush after the quiz. I didn't have much time. So with task 6, we have this music rating site. This I left all the data from last semester just because this is a smaller class. I didn't know if we'd get enough data to really make this interesting. So I left all the data from last semester. You can see, some people are really funny, haha. But we have all this data of songs that have been rated. Feel free to add your own data as well. And then right here for testing purposes, you have this ratings.csv, which will be all of that data in the format that the homework's expecting. So you can go to this link. You could grab it all and then paste it into a data file or download the file, right click, save as, and have all of this data to work with while you're writing your homework. And this is in the format song ID, which will be a Spotify ID. So if you want to listen to the song, go to any song on Spotify, go to the URL and paste this in place of the ID of whatever song you went to. So you can get these songs, or just click on the links. I'm not logged in right here. I think I still can. Yeah, but I might get ads. No, I just can't. If you want to check out the songs. So that's the idea here. You have data in song ID, which is the Spotify ID, artist title, reviewer ID, and rating. So each line is a rating for that particular song. And you should be used to all of this data. You've been dealing with this data for a few different tasks now. But now we're actually going to use that class you've written and populate it with actual data, real data generated by CSE116 students. And then likewise, we have movies data. This I just got from the internet, so we weren't rating movies as well. But let's take a look at this also. We have movies, which is going to be the title of the movie, and then any number of cast members following that title, all comma separated. So the name of the movie, so Toy Story, starring Tom Hanks, Tim Allen, etc. Jumanji with Robin Williams, etc. Father of the Bride Part 2. And we have lots of movies. And these will go along with the movie ratings from task 7 that I just showed. So this is going to populate that data for the movies class that you've been working with. We're finally going to have some big data to work with as we're building these classes, as we're building this project out. And it's 4,575 movies. It took me a long time to trim this data set down. It's from a data set. If you want to use all of the data, by all means, go for it. But it was a lot. It was, I believe, gigabytes. So I had to write a whole bunch of code to trim it down to just the movies with the most ratings and popular cast members and stuff like that. Just to do whatever I can to trim it down. And then you're going to create test files for this. So a big part of your task for this one is the testing part. When you're testing, make sure I made this image big enough, I hope, that nobody misses. I still get this question every last semester, I guess. This is the only semester I ran it. But in your package, create a file named data, all lowercase letters, and put your data files there. that you're going to be testing with, because you're not going to test with 4,575 movies. You're never going to test everything in whatever's returned to make sure it's everything that you expect. So put your test files here, and then test read songs and read movies, which will read the two files of the formats that we just saw. Read songs is going to return an array list of songs. Read movies is going to return an array list of movies. There's a few things to be concerned about with this. Which one do let's start with movies because it's the easier one. I probably should swap these because movies is easier to work with and easier to test. So with movies, you create a file with just a few movies, and then make sure that when you call the read movies method with the file name of your test file, which will start with data / and then the file name, then make sure that the returned array list contains all of the movies in that file. This line I should probably just remove. But I do want to give a warning about this. So the movies can be returned in any order. So your tests should check the array list and make sure the returned array list and make sure it contains all the movies you expect, but they might not be in the order that you expect. They might not be in the order that they appear in the file. The reason this trips students up is that my correct solution in Autolab does just return the movies in the order of the file. So when you don't test for that, it just works and, oh good, I tested movies and everything works fine. I didn't do the thing that Jesse warned me about, and my tests worked. The problem is, what does trip students up with that is the same thing is true with the songs file, the songs method, but with songs that you do have to test for this. But with the songs, my correct solution does not return them in the order in which they appear in the file. So students testing read movies and just going through the array list and checking if the movies are there in the order in which they appear in the file, you get away with it there, which I should just shuffle my results so you don't get away with it there. You get away with it there, and then they always go to read songs, and they're like, why is my test failing? Why am I failing a correct solution? I said, did you worry about the order? The songs returned in the array list may appear in any order. And they say, well, I didn't do that for movies, and it worked. Like, okay, but you were supposed to. I just didn't check for that specifically, which I should just check for that specifically, but it is what it is. So the songs will not be in that order. So when you get to the songs and it's not working the same way as movies, it's because the songs I did properly, make sure you actually are testing it properly. They can be returned in any order in the array list. The array list will not be in the order in which the songs appear in the file. So just have a heads up for that one. This bullet point is not enforced. This bullet point is enforced in Autolab. What makes songs a bit trickier as well is that, before I move on to that, the linked list of ratings. So you're going to have to call that add ratings and populate the linked list of ratings for each song. What makes the songs tricky... No, wait, I'm mixing my points up. In that linked list, those will appear in the same order as the file. Just because I didn't feel like making you go through a linked list that could be in different order. That's pretty tricky to test. It just takes a lot of code and doesn't really test polymorphism. So those will appear. So if the same song is in the file 4 times, the order in which it appears, like 1, 2, 3, 4, the ratings in the linked list will be in that order. So testing the linked list is much simpler. But when testing the array list of songs, they can be in any order. So you want to make sure you go through your expected for each song in your expected array list. Go through the returned array list and make sure that song is somewhere in there. It doesn't matter where, but somewhere in there. So what makes the songs a bit trickier, songs is a bit trickier than the movies, is that when a song does appear multiple times, we need to be able to handle that in some way. Now, the countries example that I did in lecture was meant to parallel this read songs. The big thing is when you find a song in the file for the first time, you want to initialize that linked list of ratings. But whenever you find the song for the second or subsequent time, you want to add that rating to the existing song object. You don't want the bug where if a song is rated multiple times, you only have one of those ratings in your array list, which usually the mistake students make is the last rating that appears in the file is the only one that makes it into your returned array list of songs. That's no good. That means every time you found a song, you just added it to your array list with the rating from that line, and then replaced whatever song object was already there with that song. You don't want to be doing that. So figuring that out is probably the most challenging part of this homework assignment. Oh, I said polymorphism. This is about reading files. But this part doesn't have anything to do with reading files, but the rest of this does. So taking this file of data and getting all the data into a data structure. And what happens when a song has been rated multiple times? That's the big thing to figure out. That's probably the big challenge of this homework, is figuring that out. Figuring out a way to do that. Is there anything else I want to say about this one? I don't think so. No questions. If no one asks questions, I think I'm going to go through task 5 and then I think I did go through task 5 already, right? Yeah, I went through this one in a previous lecture. Yeah, I'll wait a little bit, see if there are questions, but I think I'll actually just end this lecture early. I got everything out there that I needed to get out. Went over, introduced some homework assignments. I've mentioned some of the common questions I'm getting in Piazza. I think you went over task 5. Okay, cool. Yeah, I'm not going to go over it again then. There's no reason to. When lectures are recorded, there's no reason to say things twice. I repeat important points during lectures like 5 or 6 times. I try to. But I'm not going to do a whole topic more than once. Yeah, absolutely. Recursion's useful and possible in Python. Cool. Yeah, I did common questions I was seeing in Piazza. I kind of did that off the top. Take care, mouse ball. Yeah, I think we just end this lecture early. It's only 17 minutes early, but yeah, I think we just end it here. All right, take care, everybody. I'll take a break as usual. At least by 2, I'll be in office hours. Might pop in a little early. We'll see what the queue is and everything. All right, take care. If I don't see you in office hours, I'll see you Thursday.